No, that's molarity. I have to switch to molarity. So you get molarity. That is the pH. Okay. Okay.
Yeah,
It's still super sketchy.
you did a group effort, Mr. Moore.
Yeah, I got.
It's still super sketchy.
I'll take it. I'll take it. No.
Wait, what's number 5?
Wait, what? There's a 5. Oh, they have point number 5. The actual
But it says it's charging now.
Wait, let me see my thing. Yeah. Because, see, you have to switch anyways, because you're stuck with only this. You have no H plus. So then you divide by 0.08. You divide that by 0.08.
Okay, my friends,
Yeah.
were you able to come up with 3 pHs?
Too easy.
Still doing it? Okay,
Wait, we got the rest of them.
can I just ask, now don't answer if you're still working. What did you get for the pH of point number 3? Go ahead. How much? For 20 ml, the half liter.
Oh, okay. 5.23. Yay.
I want to. Actually, no, I don't want to. You
5.23.
Yeah. I'll let them just sit on you and die.
Are you saying you're? Are you?
What?
Are you? Like,
Nate, turn around.
Okay.
What about 30 ml?
4.75.
That works.
Yay, I agree. Yay.
Oh, it looks like there's a buffering effect going on.
Oh wow.
Quick drop at first, but then it kind of levels out. And then what about a 40 ml
3.27.
equivalence point?
Yeah, 3.27.
It gets super low.
Super low?
Oh
no.
Mid-low,
It's a commendable.
equivalent low.
I'm trying.
It looks like a curve, like curve.
It's commendable.
What about? Yes, Lena.
Let's do another point. Squad.
We didn't hear that. Can we do one more data point, please?
Wait, what did we not hear?
50 ml of hydroxide added. Would you do that one? That's going to be past the equivalence point. I just said hydroxide, didn't I?
Yeah.
50 ml of hydrochloric acid, the strong acid added. So that's past the equivalence point. Should be in excess of hydrogen ions. Would you try that one? 50 ml.
Or, I don't know, I put it in
Oh. I am sensing smell of stoichiometry.
I smell it. Yes.
When you find malaria, and then you do the whole
Wait, where's about
when we do the C5 and then plus, and then going to 5 H plus N plus yeah. I'm waiting like 2.6. It's 1.96 is the base. Wait, 1.95 equals it. It's 1.95.
I got 94. Get on my
Never mind that. Get on our
Okay.
I'm sorry. I'm still gonna call you.
What the heck?
No, it's too sick.
I didn't do anything.
It's too sick.
You insulted yourself by saying that you could kill me by saying that.
Negative log 0.011, not 0.0111.
You do?
Yeah.
Wow, that's something. I'm kidding. I'm kidding. No, are you kidding me? I'm the biggest person in this class. I Oh my god. I can see them go. Keep them guns out of the club. Wait, you got 1.95?
Are we getting 1.95?
Yes, sir.
I got 1.96.
He's done.
When you get an answer in your calculator, just subtract 100th and we'll be fine. Everybody will agree. So for 50, we're down here. And I have to say, that I notice when I connect these points, we have this sharp drop, and then the leveling off that we expect in the buffer. But then we have the drop like this, and then it's going to kind of do one of these. Now, after that very, very significant drop at the beginning, it almost makes the equivalence point anticlimactic, doesn't it? Well, I mean, that doesn't look much like, that looks more like an equivalence point because it's steeper. Agree?
Yeah.
The answer to that is, it's because this pyridine is such a weak base. The weaker the base is, the less defined your equivalence point is.
Because the stronger the acid.
The acid is stronger than that thing as a base, that's right. Yep.
Everything's coming together now.
So always expect when you're titrating a weak, either stronger acid or base, that you're going to have a very quick jump in the pH. Then it kind of levels off where it's a buffer, and then just look for those inflection points past that buffering region to estimate what the equivalence point is. Yes.
So basically,
Yeah, you guys keep saying that.
what you're saying is pyrimidine is like, or pyridine or whatever, is like the Romans, and HCl is like the barbarians.
Wow.
No.
That's kind of what I'm saying.
Wait, is that like English? Like AP World History?
That's world, yeah.
We have a push. We have to graph.
We have the angry Russian sharing the history with us. Sophie?
Will we have to graph on the quiz or not?
What was the last one?
I mean, I could kind of leave that open and say, well, maybe, but honestly, it's not going to really help. I can't give you an entire graph to make, so it's not going to do any good for me to have you plot random points. I will ask you to calculate the pH at different points, no graphing them.
Okay.
Oh, thank you.
That's not really a help. Graphing, plotting points, not that hard. Yes, Varun? Yes, we'll do it for polyprotic acid. Like if you have a diprotic acid, you'll get 2 equivalence points. The second one, because it's weaker, is going to be very, very gradual. But yeah, you just look for the change in what? Slope. When what? Monday.
Polyprotic. Oh.
Ready, Vinay?
Yes, sir.
Okay, we're going to now take a look at a graph. I want you to take a look at this graph. Artenia, you have a question?
Yeah, I can't seem to find the
Wait, should we?
equivalence point.
Is that the last
I
one?
get like 8 points
You can't what?
for the equivalence point. I get like
pH?
Yeah.
Not that I've erased it already?
No, I mean I know that like the steps. It's just like I think. I don't.
Wait, was that the last one?
So did you use the Ka? The something times 10 to the negative 6th?
6. I put it on 8 one.
No, yeah, you can't use the Kb anymore because it's an acid solution when you're at the equivalence point. So you got to take Kw divided that.
But I said C5H5NH plus yields to C5.
Yeah.
Oh, okay,
And then that's an acid.
That's an acid. Okay.
Right, so it's Kw divided by Kb equals x squared over 0.05 minus x.
Thank
You were just using Kb for that, weren't you? Yeah. So remember, you have to change it over at the equivalence point. You have to use the conjugate only. All right. I don't know if you need to take the time to write this out. When you wrote down that a titration of a weak acid is basic, well, then the opposite. The titration of a weak base would be acidic at the equivalence point.
All right. Let's see first.
Yes?
Wouldn't this only be in the case where the acid is weaker than the base? Then it's conjugate. I mean, the base is weaker than its conjugate acid, or would
No,
this be for any weak acid?
because at the equivalence point, you don't have any more base. all you have is the conjugate acid. No matter how strong anything is, the only thing that's dictating the pH is an acid, so it will be below 7. Okay, and the same thing is if you're titrating a weak acid. It's going to be left as the conjugate base, so it'll be basic equivalence point. The only time you have a neutral equivalence point if it's a strong acid, strong base titration. Okay, would you take a look at this graph and determine whether this is the titration of a weak acid or a strong acid? And your answer should have 2 supporting points.
I have 2 supporting points.
Give me one of them. Which one is it? Is it a weak acid or strong acid? And give me 1 supporting point. Go ahead.
I would say it's weak, and I will give the equivalence point as one of my things.
Why? What about the equivalence point?
Because it's not at 7, it's a little higher.
Right. It's got a equivalence point, an equivalence point that has a pH of about 9. It's a basic equivalence point, so it's got to be a weak acid. What's another reason that this is a weak acid titration, Varun?
It's like its general shape goes from like down to like up-ish, and that's like generally 8 to 5 almost strong.
Yeah, it's that quick jump and then the leveling off. Yep. A strong acid doesn't do the quick jump. It just very gradually goes up. It's just the shape of it. They're different in shape. Yes?
So when we say it's a weak acid, do you say like the titrant is the weak acid?
No, well, what you started with.
Oh.
The titrant is this thing down here. It's what you're adding to it. So yeah, you know that it's a weak acid you're starting with because it starts with a low pH. The titrant would be NaOH in that case. Also, another reason is, I don't know if you were getting to this too, Varun, the equivalence point for a strong covers usually about 8 to 10 pH units. It really starts low and goes way high, all in the matter of a very small addition of NaOH. Yes?
So can we generalize that? I'm sorry, I forgot. I remember.
I only have one thing left today, and that is to show you one of the book problems that I get a million questions about. Can we go over one of those?
Mm-hmm.
Number 53 in the book.
Ay.
I was looking for your reaction, and now what did you think about 53?
I
haven't
wrote
done
it
it yet.
down and then I understood it. So it was cool.
And I want to remind you, it is not a crime to look at the solution guide. And it's not cheating to look at the solution guide. So have that help you out and be a guide for you as you go through and to try to figure out. Some of these are really hard problems. I'm going to show you this, not because I want you to look at this and say, oh, we've been studying this for all week and I still don't get it. I must be stupid. Don't think you're stupid. This is a hard question. So that's why I want to show you. Now, if I can show you how to do this and it makes sense to you, then you'll be ready to do other difficult ones like this. Because I think 54 is assigned as well. And 54 is similar to 53. So let's take a look at 53. What quantity in moles of NaOH must be added to 1 liter of 2 molar acetic acid to produce a solution buffered at 3 different pHs?
pH equals pK. Is A at equivalence point or no? No. It's when there's the same number of moles for each mother, right? Yes.
Yep.
No,
What do we call that
that's
point?
not the equivalence
Halfway
point.
point.
The
Halfway
halfway
point, that's right.
Yeah, the halfway thing.
Okay, so how many reactants are there in this problem?
2.
What are they?
HC2H3O2.
Okay, wait. HC2H3O2. Classify that. What kind of compound is that?
Weak acid.
That's a weak acid. Then what's the other reactant?
Strong base.
When a weak acid and a strong base react, what happens?
Buffer, 1 direction.
One direction. That's right. It's going to go one direction. You got the hydroxide ion. Again, I'm forgetting about the Na. I don't even care that it's there. It's a spectator. It does nothing. And then the acetate, I'm sorry, not the acetate, the acetic acid, HC2H3O2. And I want a one direction arrow. That's it. You can't even hear that without smiling, can you?
No, I can't.
I say that for you, Chinook.
Chinook's not even here. Wait, where is he? Oh, Chinook!
No, I knew where you were.
Oh, he's in the back.
How did you?
Okay,